Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on September 5th, 2025, about 3 days ago. The main contribution is a real-time, feed-forward system that predicts precise camera poses and high-quality point maps while streaming, matching state-of-the-art quality without sacrificing speed. The paper is titled WinT3R, Window-Based Streaming Reconstruction with Camera Token Pool, and as we will see later, the results are really impressive. This paper introduces a sliding window interaction scheme and a compact camera token pool that together deliver reliable online reconstruction at over 17 frames per second across diverse datasets. Alright, Figure 1 presents the high-level pipeline, which shows how streaming frames are handled in overlapping windows so the model stays real-time and still shares context. This figure illustrates that each window outputs point maps while also emitting a compact camera token that goes into a growing token pool. The next window then attends to that pool so pose estimates stabilize and geometry sharpens. The film strip at the bottom emphasizes continuous streaming at 17 frames per second. Alright, Figure 2 shows how one sliding window processes frames to produce point maps and camera poses in real time. The window groups adjacent frames so tokens can share context, which reduces drift because nearby views reinforce each other. Image tokens pass through a dual-branch decoder with state tokens, then a light point map head outputs local geometry. Camera tokens flow into a growing camera token pool, and a camera head predicts poses. So, Figure 3 contrasts three attention masks, which control which tokens can talk to which others during processing. The figure shows full attention, where everything sees everything, causal attention, where each token only sees past tokens, and sliding window attention, where tokens see the current window and earlier windows. Sliding windows matter here because they keep compute bounded while preserving short-range context across overlapping frames. That balance supports real-time speed without losing crucial geometry cues. So Table 1 reports 3D reconstruction accuracy, completeness, and overall error, and lower is better because these numbers measure distance between predicted and true points. The table shows consistent gains on both DTU and ETH3D, with the overall score improving against all online baselines. These results suggest the sliding window interaction and the camera token pool jointly raise geometric fidelity without heavy computation. The improvements appear across object level and scene level settings, which indicates strong generalization. Wrapping up, two takeaways stand out. The sliding window interaction keeps computation bounded while preserving rich cross-frame context, and a compact camera token pool supplies global memory that stabilizes pose estimates. Together they deliver state-of-the-art online reconstruction at real-time speeds, which opens doors for robotics, AR, and live mapping. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.